All right, so we are going to do the last section on factoring then that we're going to work on in this chapter. And all we're doing today is combining all the types of factoring that we've done to simplify longer, more complex polynomials. So sometimes, you guys, the ones that we've looked at so far, there's only been one step to it. It's either been a GCF one, or it's been a grouping one, or it's been a difference of two squares, or a perfect square, or just a standard trinomial factor. But what we're going to talk about today is we're going to talk about how to combine all of those so that we can solve more complicated polynomials. So before we start that, what do you think it means to be fully factored? What do you think that means? If I say something is fully factored, what do you think that means? What do you mean by that? All the pieces are prime, right? You can't factor any of the pieces anymore. So for instance, in one that you guys just did, so like this one right here, this first one, number one broke down to what? And x plus 3. Can I break these down anymore? Can either of these pieces be broken down anymore? No, these are prime. There's no GCF. They're not trinomials. I can't do anything else with them. So we would say at this point, this thing is fully factored. Basically, that just means it's factored all the way. All the way that it can be factored, it is completely done. So looking at these, just looking at A, for example, how many factors are there in A? 2. What are they? X squared plus 4 is one of them, and 2x is another one. Okay, so x squared plus 4 and 2x are the two factors. And I want to know, is this fully factored? So when you're looking at that, you have to say, okay, can I break this down anymore? And can I break this down anymore? And looking at 2x, can I break that down anymore? No, because 2 is a prime number, and I can't break it down to anything else. What about x squared plus 4? Is there anything that goes into both of those? 2 doesn't go into x squared. X goes into x, but it doesn't go into 4. Yeah, because if we're trying to factor it. What do you mean? But can you take that out of 4, though? It doesn't go into 4, right? So is there anything you can factor out of either of those? No? So then that one's fully factored. That one's done. Those are both primes. Now, this would be different if it said this, 2x and then x squared minus 4. Because what is x squared minus 4? Think back to what we talked about yesterday. What is x squared minus 4? It's a perfect square. What kind of math is in the middle? Subtraction. So what do we call this thing? Think back to what we did on Tuesday. What's another word for subtraction? Difference. How many perfect squares are there? 2. So it's a difference of 2 squares. Difference of 2 squares. So how does a difference of 2 squares break down? Yeah, that's right. Good. And then we would still have this 2x. So in this case, we could factor it more. So this one was not fully factored because there was more that you could do. Whereas this one, there's nothing else you could do. How come you can't factor this one the same way that we did this one?
Well, couldn't you possibly do 2x plus 2x plus 2?
No, why not? What would that give you? If I check that, what does that give me in the middle? 2x and, which is? Well, but 2x plus 2x gives me 4x plus 4, so that doesn't give me this. How come it works with this, but not with this? Think back to what we talked about on Tuesday. Because what happens here? It cancels out. Okay? So it cancels out there, but it doesn't cancel out here. Okay, so that's why this one right here, the actual example, that's why this was fully factored, so it was already done. Whereas this one, you could factor a little bit more. Okay, look at B. How many factors are in B? How many factors are in B? Not 3. 2. There's 2. This is a factor, and this is a factor. Are both of those prime? Are both of them fully factored, or can you simplify one of them or both of them? Which one can you simplify? The one to the left? How come? Because what goes into 2 and also 6? 2, so you can take out a what? A 2, what's that called? The 2 is the greatest common factor. So you can factor out a 2, and now what does this look like? Where's the 2 go? Outside the parentheses, and then Rodrigo, you'd get x plus 3. Perfect. Can you factor this one anymore? No, because there's no GCF of x and 5, so you're done at x plus 5. Okay, so when we say fully factored then, that means that everything is broken down into something smaller if it can be. If it's already done, then you just say it's fully factored, okay? So it's already down to its prime factors. But here, this one could be done because it has a GCF. All right, so when you're looking at these, there are steps to follow to make sure that you don't forget to check for everything. So the way that I record it is first look for a GCF, then look for a D2S. What's D2S again? What's D2S? Difference of 2 squares. So give me an example. What does that look like? X squared minus 4. Good. So like x squared minus 4. That would be a difference of 2 squares. So you should always look for those. And then the last thing you should look for, what's QT? What's QT? Quadratic trinomial. Perfect. Quadratic trinomial, which is like x squared plus 5x plus 6, because you can break that down even more. Okay, so those are the 3 things you should look for. So when you're looking for, can I factor it more, the first thing you should look for is a GCF. And the reason you want to look for a GCF first is because if you factor out a GCF, then the numbers all get smaller and they all get easier. All right, so that's why you always want to check for this first. Difference of 2 squares you want to check for just because it's an easy pattern to spot. So looking for it makes it a lot simpler. And then quadratic trinomials are any trinomial that you can break down. So like what would this break down to? What would this one break down to? X plus, no, 3 and 2. Why?
Because 3 and 2, they multiply and it also adds 5x.
Say that again.
3 and 2, they multiply together.
Good. They multiply together to give you what?
6.
Good.
And they also add to give you
Perfect. They multiply to give you 6 and they add up to 5. Okay? So don't forget, that's the stuff that we did like right before the quiz. Don't forget that all of this you still have to remember for this test, okay? So we're just putting everything together. So we started with GCF, then we did quadratic trinomials, and Tuesday we talked about difference of 2 squares and perfect square trinomials. This is the order you want to look for it in. So whenever you have a more complex trinomial, you want to look to see if you can factor anything out. So again, a GCF is always the first thing you should look for. So looking at this right now, is there a GCF that I could take out?
Yes.
What?
2.
Positive 2 or negative 2?
Positive.
I'm going to disagree.
I mean negative.
How come you should take out a negative 2? Because 32 is a negative, but more importantly, yeah? Well, what's the first digit? Negative. And you want your first digit to be what? It's just easier if it's positive. So if you factor out a negative, this will turn this into a positive. Okay, so I can take out a negative 2. What else is in everything? X. So I can take out not only a negative 2, but also x. So if I factor out a negative 2x, What am I left with here? y2. Okay.
Minus 8x, I mean 8y.
Plus or minus?
Minus.
Why is it minus? Good, because you changed the sign. All right, and then what about this one? Plus what?
Negative 16.
Not negative 16. We're taking out a negative 2, so positive 16. Okay, so you factored out a GCF. What's the second thing you should look for? Difference of two squares. Is this a difference of two squares? No, so we can move on. The last thing you should look for? Is it a quadratic trinomial? So is this a trinomial?
Yes.
1, 2, 3, yes. Is it quadratic?
Yes.
Yes, so can we factor it? Probably so.
It is.
Yeah. Second degree? Quadratic? Okay, so that means it's going to break down to something that gives me 16 that adds up to 8. So what do you think? 4 and 4. Good. Okay, and then what would the first thing be? Y. What would the signs be?
Negative, positive, negative, positive.
It can't be negative positive because that would give me a negative 16.
Negative, negative.
Got to be negative negative. If it were positive positive, what kind of 8 would it give you? Positive 8. You need a negative 8, so it's got to be negative negative. All right, and then what do we do with the negative 2x? Just bring it down. Okay, now this is fully factored. So this has been factored all the way. So you start with a GCF. You checked for a difference of two squares. It didn't have one. And then you factored the quadratic trinomial. And then it's done. Now it's all prime numbers. Okay? This is prime, can't be broken down. Neither of those can be prime. So how many factors did we just break that down into? 3. There's this one, and this one, and also this one. Okay, so 3 factors. 2 of them are the same, but 3 factors. Okay, so when we're fully factoring, those are the steps that I want you guys to follow. Okay, let's try this one. What are you going to look for first? Okay, is there one? I agree that it's 3. No, I don't think it's negative because the one in front is positive, so just stick with that sign because that's the one that you want to be positive. 3n squared. Why do you take out a 3n squared? Smallest exponent. Yep, because that means you can take it out of all of them. So then what would that give you here? Be 1n 2. Good. Do I need that one? No, but I can. It doesn't matter. And then this one would be what? 5n1. I don't need that one. All right, and then plus 4. Perfect. Okay, and the reason that works is because we take 2 n's away from here. That gives us 2. 2 from here, that leaves us with 1. 2 from here, and now we've got none. All right, what's the second thing you should look for? Second thing. Difference of two squares. Is this a difference of two squares? No? So then what should you look for? Okay, is this a quadratic trinomial? Yes? And you recognize that because it has how many terms? 3 and the degree of 2. Okay, so what does n squared break to? N and n. What multiplies to 4 but adds to 5?
2 and 3.
2 and 3 multiplies to 6.
What multiplies to 4?
Danielle? Negative 4 and what? And negative 1. 4 and 1. 4 and 1. And they both have to be negative because that would give me what kind of 4? Positive. But what kind of 5? A negative. Okay? Now, am I done? Yeah, there's nothing else you can do. You can't break this down anymore. I guess you could write it as 3n times n, but that would just be a waste of ink. For you, not for me. This doesn't cost anything. Okay, that's fully factored. So when you're on a test or a quiz and it says fully factor, if you do not get down to this step, your answer is not right. Okay? All right. So that's it, and then I want you guys to try these practice. There are 8. There are 8 of them. I'd like you to try them all. You have a lot of time, so I'd like you to try all of them.